field. Let's say I have charge here. I have the charge here, negative charge and a positive one. This is the equilateral at the edge of the equilateral triangle. Okay. So what happened with the electric field at some point, some position? I can use the electric sensor, right? The sensor. So I can put it here. I can put it here. Oh, sorry. I can put the sensor here so that I can know what the electric field at some position is. Okay, and because this is symmetric, so I can guess, right, or predict something about the field. Okay, when I want to know the electric field everywhere on the board here, I click on the electric field, right, and you see the electric field at some point here is given, right? For example, here, here, and here. When I move the sensor to close to this point, then you will see that the white arrow gives us the correct direction of the electric field and so on. Now, when we talk about the field, we have electric field. The electric field, from the electric field, we can calculate the flux, the electric flux. This is Q multiplied with E. Okay. So now what happens when I have only one charge here, only one charge, right? And I have electric field somewhere, this point. But what happens when I move a charge around in the field of this charges? For example, I move from here to here. What happened? What happened? Of course, when I move the charge from here. So the electric flux, let's say I have a positive charge. So the electric flux will have this direction. But when I move it to another new position, right? So you can see that on the way from here to here, the flux will change the direction and the magnitude too, right? So let's say how I can calculate the work done by this charge, by this flux. Sorry, I have to turn on the recording. Okay, let's formulate the problem again. Imagine that I have a test shaft. It can be the yellow point here. And I put it in an electric field of a single charge, the red one here. Okay? Then, when I move the charge from this point to this point, you can see that the force that this charge acts on the test charge change in direction and magnitude too. The question is, how can I calculate the work done by the force along this path? How can I do that? And further, how can I calculate the energy of the interaction between the positive charge here and the positive charge here? For example, when I fix the charge here, what happens when I release the charge here? I don't keep it in my hand anymore, but I release it. without initial velocity, what happened? You will see that the track here will push the test track so that the test track move away, right? Move away. But when I have an initial velocity, it can move in another way, like this, not along this direction, right? So somehow we will talk about the energy, and we say, okay, when I have a positive charge here, right? Now I remove the sensor. I can calculate the force that acts or interact between the two charges here. It's the just an application of the Coulomb's law. But now, when I release them, what happens? They will move, right? They will move away from each other. So I say in this case, I have some energy that is stored in the system. When I release the charges, they will move. In this case, this is similar to a spring or to the gravity. For example, what happens when you hold in your hand a rock in your hand and release that? What happens? The rock will fall down. Okay? So we say the rock and the earth has a so-called potential energy. And we can use this energy, for example, for making or producing electricity. Okay? When you have the water fall down, then you use the generator and you have current, electricity. Okay. It can happen when you, for example, you have a negative and a positive charge. They will attract each other. But at this distance, the system will have the potential energy. So in this case, we don't talk about the force anymore, but we talk about the energy. The energy. Then how can we calculate, let's say, the potential energy of this system? Or maybe more complicated. We have more than one or two charges. So what is the potential energy of this system of charges? Then, first of all, let's imagine we have again, we have a test charge, a positive test charge at this position. We can calculate the force, and we can calculate the energy of this test charge and this, we call it the charge here, we can call it the source charge, the test charge, the source charge. Okay? And we define a so-called potential or electric potential. Electric potential, we call it V. For example, I can use the gauge here to measure. For example, when I move it around, you can see the reading here. This is 6.7.98. Okay, 0.980 volt. When I move it close to that, I have 29.13. When I move closer, I get a very high value. And the unit here is volt. So what is volt? Right? We are talking about the potential, electric potential. Okay, so electric potential everywhere. So at this point, we have how many volt do we have here? 6.434 volt. Okay, so how can we calculate, not measure? Now we are measuring, right? But how can we calculate that? So we start with the new chapter, chapter 25, electric potential.